Okay, I'm back with my Desmos graphing calculator to look at number 2 from week 5. And we have the function. This is telling me here on the graphing calculator I'm doing a function. 3 over x minus 1, and then plus, excuse me, x minus 2, and then plus 1. I'm going to show you, and this is correctly graphed here in red. I haven't looked yet, but I'm sure a bunch of you have typed it like this, and it's not showing the way I wanted it to on the Desmos, but you put 3/x minus 2, then plus 1. Can you see that the blue graph here is not the same thing as the red, which I've told you is correct? You've got to make sure that the 2 is included in the denominator. So you know I will not accept sloppy notation if you have typed it looking like 3/x and then minus 2 all on the same line, unless you've put parentheses around the x minus 2. Okay, let's get rid of that. Here's our function, and we need to look at it and we need to determine the domain and the range for this function. Domain, you know how to do. You look at it and you see, you've got two problem areas that you have to be concerned about: variables in the denominator and variables under even roots. Well, the only thing you have to worry about is right here where we have this x minus 2. If x were equal to 2, then we would have a problem, so we have to exclude 2 from our domain. Now let's look at, I believe this will let me graph the line x equals 2. And so you may be familiar with the concept of an asymptote. It's here, see my graph never really exists where this green line is, because my graph is the red line. It's going to approach it down here and it's going to approach it going up here, but it never will really exist there. So that's why we're excluding the 2 from the domain. Now, many of you have, you've a couple of different ways you can describe this. You can do this with set builder notation, the squiggly line of, well, I'll tell you what, I'll just put that in the message where I'm typing to you, but it's the squiggly line set of all x such that x is not equal to 2, or the interval notation, parentheses, negative infinity, comma, 2, parentheses, union with 2, parentheses, 2, comma, infinity. That's even hard for me to follow in my head. But you could write the domain in either type of way, but the main thing is that you have to exclude 2 from your possible values for x. Now, range is what's going on with your y values, and at first glance at this, you might think that the range will be all real numbers because it goes on forever here, it goes on forever here, you know, and everything. But I want you to look at the line y equals 1. This is a purple line here. Can you see that my graph, my red curves here, never really will touch that 1 either way from top or the bottom? Now, I know I'm asking you to, use your imagination to see that, but let me look at this mathematically. Go back to the original equation here. Can 3 over x minus 2 ever equal to 0? That's the only way this whole expression would be equal to 1, right? Is if 3 over x minus 2 equals 0. Well, if x were 2, we'd have 3 over 0, which is undefined, so our function doesn't even exist there. If x were 3, we'd have 3 over 1. If x were negative 1, we would have 3 over negative 3. There's no way that we can come up with 0 added to 1. So we have to exclude the y values of 1 from our domain. The easiest way is set builder notation that says the set of all x such that y is not equal to 1.